So when you look at key management, you want some kind of system that balances between having it simple for the access of the keys and then preventing the unauthorized access. If you look at securing the database, you should also look at network encryption, having a strong authentication method, and then we'll get into more of the different methods of encryption that you can use within the database. So we can take three different approaches to key management, where you have a single key for the entire database, or different keys for each row of tables within the encrypted data, or a combination approach. I had mentioned the TDE, that's part of Oracle, and with that there's two modes of encryption. One is column encryption and one is table space encryption, and we'll get more into that in just a second. So if you look at the single key approach, there's some advantages to doing it this way. One is that you're going to use one key that's going to be used to get to any of the data in the database. With that, then your routines that do the encryption, decryption won't need to select keys out of a table and store them every time a record is manipulated. That's going to cause better performance as far as the CPU cycles and the I/O operations. But there is some disadvantages, of course. You're going to have one point of failure as far as using the single key. And if you change the key, then you're going to have to change it at all the rows in all the different tables. So you have to weigh those two pros and cons when you make your selection of how you're going to handle your encryption. So let's look at using a key for each row. Well, no doubt with this you're going to use a different key for each row in the table, and it's going to be more secure than using the single key, so that even if someone succeeds in stealing the key, only one row will be compromised, not the entire table or the database. The disadvantages is the keys make proliferation of the keys makes it extremely difficult to manage them. Okay. Also, because the encryption and decryption operations need to generate or retrieve a different key within each row, then you're going to have some performance considerations that will be an impact. So let's compare the different approaches. When you're looking at the one key approach, it'll be real easy on the key management. It's straightforward. One key to manage. It's going to create access and backup. You can place the key in many places, convenient for the application to be able to access it. But if the key is stolen, then the entire database will become vulnerable. So if we compare it and look at the one key per row instead of just a single key, then you're going to have a number of keys that's going to be equal to the number of rows. So that's going to make key management more complex. There's going to be more data to back up, more storage, and so on. So that's going to have an impact. If you compare it to the single key being stolen, though, if you have one key per row, if the key is stolen, then only that corresponding row is going to be compromised, not the entire database. So overall, you have a more secure system, database system, but once again, it's more complex and it's going to require more resources. Okay, let's look at some other approaches then. You could have a single key per column, where the same key is going to apply to all the different rows. Another alternative would be a key per table, regardless of the number of columns. Or you could have a key per schema and so on. So you could break it down to different approaches. The key thing that you would look at is that the number of keys that you're going to manage will decrease by using the different methods with all these different options. But of course, with that, then the vulnerability of the data would increase. So we've looked at different ways that we can do key management and why encryption is important. But as I mentioned before, There's some key things that we need to keep in mind. With encrypting the database, we should also look at network encryption and having strong authentication. We're looking at encryption at storage level, at the application level, and the database level. We mentioned last week that your security was as strong as your weakest link, and so we have to take all things into consideration.